part of the reason I think I'm here today, unfortunately, is because this guy, who's a beautiful bird called Canada Warbler, has been declining quite dramatically. And as a result, it's raising awareness about maybe there's some stuff going on in the boreal with songbirds that we need to bring up. My emphasis, I'm going to tell you quite a bit in the first half, is talk about the Canada Warbler specifically in terms of what we know and what we need to learn to know. And then I'm going to bring it back to just birds more generally and talk a little bit about kind of some future applications, the things we're doing with the energy sector research that AUPRF and PTAC are supporting, and particularly in the perspective of what is recovery. So, a little bit Canada Warbler and status. We're going to go through that first. We're going to talk about habitat selection, and I think what we've heard is a theme throughout a lot of the things today, the concept of scale. Right? When you try to measure, is something recovered? It depends. Is it local? Is it landscape? Is it the entire region? All of those have different implications for how we talk about it. We've done a lot of work on the Canada Warbler with forestry, and for good reason, I'll show you. But I think it will inform quite a bit about what you might want to do when you're thinking about from the energy sector. A little bit about what we're doing right now with energy sector mitigation. And then I'm going to talk about some of the new technology that I'm trying to apply so that I no longer have to come and talk to you about the Canada Warbler. I can talk to you about 200 or 300 species simultaneously instead of the focus being one species at a time. So, Canada Warbler is a reasonably, well, birds in general are actually reasonably well studied in Alberta. So this set of groups here is a group of people that I work with that have gone through and created what's called the Boreal Avian Modeling Project. And in Alberta, what we've done is we've taken every single point count we can find, and a point count is basically a person stands there and records the birds they see and hear. And we put them into a very large database. And in Alberta, we actually have about 60,000 points that have been sampled outside of traditional monitoring programs, which we incorporate as well. So hundreds of thousands of locations. We know a lot about where birds are. We've done a lot of work in northwestern Alberta over the last while to fill in gaps. And so what we've learned about the Canada Warbler in particular is that it's both in the northeast, it's also in the northwest, it's kind of spread throughout the province in the boreal places. But there are some very distinct hotspots, and this hotspot thing becomes quite something to think about when you're pondering managing for this species. Some people don't have to worry about it, others probably have to worry about it quite a bit. Now, why are we concerned? Those are the BBS trends for the Canada Warbler. Don't really worry about the axis. The point is it's going down, and it's going down precipitously. Some estimates put since the 1960s, the species has declined by 85% in Canada. Our rate is slower here in Alberta, and I think that's relevant, but it is still also declining. There are some limitations, though, of our Alberta knowledge. This is the data from which this comes. This is called the Breeding Bird Survey. And the Breeding Bird Survey is a volunteer program where people do surveys along roads, writing down what they see and hear. The BBS, as you can see, does not cover most of northern Alberta. And as a consequence, we really don't have a very good clue of what's happening in the boreal part itself. And in fact, some of the work we've been trying to do by collating this historical data sets, it wasn't ever intended for trend, but there were people who did surveys in the 90s, in 92, in 93. It's a very haphazard data set, but we've been putting it together and trying to figure out statistical ways to control for the fact that it wasn't a standardized effort so that we can actually look at trend. And it's actually revealing some interesting patterns in that a couple places in Alberta I've seen Canada Warblers actually increase quite dramatically. One being my study area at Calling Lake, where I've studied birds for 23 years, and the birds have actually, doubled actually in their number. So there may suggest they might be shifting around to some degree. Now what I'm going to emphasize today is the different kinds of data. And the reason I want to talk about the different kinds of data is when I talk to you about the impacts, the cumulative effects of anything, it depends on how I measure it and it depends on the scale. All right? So for these birds, we've done three major things. The first is what's called territory mapping. And territory mapping is like Gord does. He puts a transmitter on an animal, lets the grizzly bear follows around, learns what he needs to learn about that animal's behavior. We can do the same thing. And we can learn incredibly detailed, high-resolution information about how do they react to that seismic line, what tree do they sing in, all of that kind of stuff. You can get incredibly good detailed data, and it's very useful for some things. We also have what we call the human point count. I just talked about that collation of information, those hundreds of thousands of points. And they're really good for getting to lots of places really quickly, okay, going everywhere, getting information on lots of different species. But they're really bad at telling me where is that bird exactly. He could be 150 meters away from you when he calls, he could be 2 meters away. And it's really hard for people to estimate exactly where that is. So I've been working on that, and I'll talk a little bit about the use of something called an ARU as a replacement for that technology and some of the things we can do to maybe estimate distance. The other thing I'm going to talk about near the end of this talk is ARU triangulation. So this is the new high-tech solution that I'm going to propose and talk about why it's got some real potential. And I'll talk a little bit more about that in a bit. So this is what I want to emphasize. This is your major take-home from, probably 100 people doing point counts across the province of Alberta. So for those of you who don't know, the ABMI is a partner on this project with myself. We have a website called species.abmi.ca. And for the birds, there are models for every single species of bird that we have sufficient data for on that website. What this model shows you is we have the different forest types along the bottom. It's upland spruce, pine, deciduous, mixedwood, black spruce, larch, and a variety of other polygonal type of human disturbances. What I want to emphasize here, this is what we know about the Canada Warbler. They like deciduous forest, and they like old deciduous forest. Now there's a very high, large confidence interval on that estimate at the top, but the pattern is very strong. Now what's important about this is that this is very different than in Eastern Canada. In Eastern Canada, they don't like old forest. In fact, they use younger forests, which is kind of odd, which makes it very difficult to think about managing something at a continental scale. But you have to take into that context when you're thinking about it. Now the other thing I want to emphasize in here is this is in our current modeling, what we're able to do with this really large big scale data set is, we've got really coarse categories, cultivated human footprint. This is what we would call urban industry human footprint. So we're pooling together necessarily because of the amount of data that we have, these categories. But there's a lot of detail in here that's important to look at. Is a well the same as a compressor? Is a compressor the same as a processing plant? Is a processing plant the same as a camp? So these are some of the things that we have to think about. Now here's what we know about the Canada Warbler from the point counts, broadly speaking, and this becomes highly relevant for their conservation. So here we have, I'm sorry, it's getting cut off a bit, but proportion of wet habitats and CTI. CTI is compound topographic index, and the birds show a very tight pattern where that they don't like swamps, they don't like really, really wet stuff, but they like old deciduous forest that is damp, so in other words, nearby streams and rivers, and they like it in fairly steep terrain. Now, steep being boreal steep, not mountain steep. Okay, so that tends to be where they are found. As well, they show a very strong relationship to the amount of deciduous forest in the landscape. So small patches of it are not near as important as very large blocks of forest. And this will become quite clear in just a second. Now when we jump down scales and we look at some of the other attributes that we can get when we measure them on the ground, we actually find some other very interesting things. So what we have here is we've also measured the birds using radio telemetry and following the birds around. And what we have on this graph here is a very strong relationship with shrub cover. Okay? Shrub cover is a predictor of where they are. It also influences the size of their territories. The denser the shrubs, the more the birds get packed into the same space. Squirrels actually influence the distribution of how they put themselves out on the landscape, and squirrels are their dominant predator. Whether it's beside a lake or whether it's in the remote forest interior influences the size of their territory. But what's very interesting is what we're going to call conspecific attraction. Okay? So the number of birds around each other influences a lot of different things. So if you have a densely packed area, you have a lot of birds in it with small territories. But one of the things that we're finding is this actually leads to reduced breeding success. More birds, reduced breeding success. But what's important about this is understanding that breeding success. It doesn't mean they're failing. What's happening is that we're getting a whole bunch of unpaired males hanging out with the really good quality individuals. So in other words, what's happening, and this happens a lot with birds actually, females don't survive as well as the males do. So there's many fewer females in most songbird populations than around males. So there's unpaired males on the landscape, and they kind of have three choices. One, go off somewhere else by yourself, be alone, and live a hermit life. That's one option. Option two is not to really set up a territory and just fly around and do what you can, and they're called floaters. And the third is to try to hold territories and then be what's called a sneaky bugger, and which is to try to get something called extra pair copulations, which is you may not get a mate, but you may get a mating opportunity with somebody else's mate, and thus actually increase your fitness. So what we've been finding is that there's much more unpaired males when you have very large, dense populations of these birds together. Now, that led us though then to ask the question, well then what's going to happen? We've got old growth forest is what they like. They like it in some fairly steep terrain, they like dense shrubs, these are the kind of things. Now forest harvesting, obviously, if you think about it, I mean, if you like old growth forest that's 160 years of age, that's going to be the stuff that the forestry companies are going to go after first. So we're trying to ask the question, well, what's happening with forestry in terms of where did the birds go? What was their abundance? And how did they behave in those different situations? So these are basically the experimental design. We've gone to about 140 different areas with different levels of harvest. Some of them have seismic lines and well pads as well in them, so we can actually model that stuff as well. But we look at things like the residual block size, riparian buffers, you know, a variety of different things like that. We're still doing some analyses on trying to figure out the exact forestry patterns that, you know, can maybe make things okay for the birds. But what we found primarily, and it's not particularly surprising, is that the more you harvest in an area, the fewer birds you're going to get. Now that makes intuitive sense, okay? But what's more interesting is this graph down here, which is that if you find a block of forest that has Canada Warblers in it, there's a very good chance that within 100 to 200 or 500 meters, you're going to have another population of Canada Warblers. They are showing this behavior called conspecific attraction, and it happens at every single scale, big, large landscape scales to even local things, where when you find one, you find a lot. They're clumping together. So I have habitat out there. I've gone to across Alberta, and I've measured the shrubs, I've measured the trees, I've measured everything, and they're identical to the place where there's all the Canada Warblers, but there's no Canada Warblers there. And it's basically because these birds are attracted to each other. And the reason is they have an incredibly short breeding season. They get here about May 24th, and they have to breed by about June the 2nd. So they really need some kind of cue to actually decide where they're going to go. And it seems to be that the birds cue on each other. They see one, and they start to attract, and it creates a node that grows. Now, from a management perspective, I think that actually gives us some opportunities relative to some other songbirds, in that we can probably identify some of these real hotspots on the landscape. And they could become like population management units. They're things that we could probably say, you know, that's an area where we want to limit our activities because there's a lot of Canada Warblers. The three places that I know of that are like that, Lesser Slave Provincial Park and the areas around that lake are totally like that. It's the highest density in the province. There's an area in the Alpac FMA near Lac La Biche that we've studied that's very much like this. And there was a third just south of Anzac, which was a great place where some of the stuff I'm going to talk about in a second was all planned to go, and then the fire took it out, so probably not so many Canada Warblers there anymore. All right, the other thing to emphasize, though, is that these birds will go into harvest blocks. Okay, so this is the percentage of birds that have harvested areas in their home range. And so some birds go up to 100, but it's very few. The odd bird is found in a harvest block by itself. The vast majority are in the old growth, and some will live across the edge. And so that's valuable because it does tell us that as forests regenerate and things like that, as well pads regenerate, as cut lines regenerate, these birds should start to use these features as part of their life. Now, when we take the big core data set that we talked about, one of the things that we see, if we use point counts, we really see no relationship between the number of Canada Warblers out in the landscape and soft linear footprint. We see a very strong relationship with hard linear, so your roads, your gravel, that kind of stuff. So your pipelines and seismic lines, using point counts, we can't really find a really strong effect. Using it on roads and those kind of things, very strong effect. So that's important, and I think we'll put some context on some of the other things I'm going to talk about in a second. Now, I'm going to switch gears a little bit, in part because the data I'm collecting on Canada Warblers, we literally we're getting it ready, it's getting set up to go so that I can give you some more of the detailed analysis of how they respond to well pad, you know, vegetation, all of that other stuff. But we have a lot more data for some of the other species of birds. And this is what I want to emphasize when we talk about technology, scale, application. We have to think about all these different things. So what we have here is I've done a bunch of point counts on well pads. So I stood in the middle of the well pad and I counted the birds I could hear. Now I could count those birds all kinds of different ways. I could count every bird I hear, no matter how far away it is, and that's what this data is showing here. I could count birds within 100 meters of myself. I don't do that very well, to be honest. I'm not the greatest estimator of distance, and nor is any other person. Or I could do it only the birds that I detect on the well pad. What's the question? And that question is fundamental because the response changes. So here what we have is reclaimed well sites. So these are sites that are certified reclaimed versus reference places. And reference are just the forest is similar to the forest that is around the well pad that was originally there. And what we have is species richness of birds. And we have regeneration stages, which I won't go into detail, but it's, you know, they're getting increasingly regenerated, or age class. So the age class of the well in terms of time since it was recovered. And we are seeing, with this unlimited distance point count, changes in the bird community in terms of the number of species that are there as the well pad recovers, right? And in fact, at this intermediate level of age, right here, this is a time period when we did something when we built those well pads. And we're just learning more about exactly what activities occurred there, but there are more birds present on those types of well pads than there are some other types of historical time periods and or activities that people took when they actually did those. But what's really important to think about when you do this is, what is your question? This last one, I'm talking about the richness of birds on a well pad and in the forest around it. So I'm talking about the edge effect, I'm talking about the well, I'm talking about the landscape context. In contrast, if I just count the birds that are on the well, totally different story. Okay, so this is for a species I've studied a lot called the ovenbird. And if you look on wells that look like this, in other words, they've been restored to grass and that's it, there are 0 ovenbirds on the well. They don't use it. If you look at the edge, there's just as many as there is in the interior. So the forest itself is fine, but the well pad's not so good. If you take a pipeline that's 25 meters wide, you see about half the ovenbirds if you stand on the pipeline and do it versus you do the edge or you do the interior. But this is using that small radius point count. If I use a big one, a lot of these specks disappear, right? So my study, my reaction of how the birds react to these phenomena depend on how I measure it. What this graph summarizes, and I won't walk through it in too much detail, but it talks about the differences that you're going to see if you use a 50-meter point count, a 100-meter point count, or an unlimited distance point count in terms of whether you find a seismic line effect, whether you find a pipeline effect, or whether you find a well pad effect. And the basic take-home is this. The smaller your point count, the more likely you're going to find a bigger effect. But you're going to have less certainty in your answer, and it's going to take more data to actually collect it. So the probability of detecting effects changes because of the abundance of data that comes into this. So this is kind of reflected here. This is the response of all birds to well pads that have, kind of have reached that grassy, early shrubby state. And basically we see way fewer birds on the pad per se than we get at the edge or the interior. But this is important. Birds are using those pads. They're singing from them, they're breeding on them, and they are feeding on them. The dominant species of the Tennessee warbler, the chipping sparrow, the Lincoln sparrow, and the clay-colored sparrow. So that's a good thing. We have birds that are using them. They're not no habitat. But I think this is actually also a really good thing, because when these guys disappear, that means it's becoming better for the species that like older forests. These guys all like young forests. You find them in cut blocks all the time. So well pads, I think we can actually start to think about comparing them and their restoration state to cut blocks, right? If you're on the right trajectory, if you're similar in your recovery state in terms of tree height and the birds that are there relative to a harvested area, you're probably not doing too bad. You're on the right path anyway. Now, to get back into the detail though, okay, this is all based on me doing things fairly coarsely. I get some good answers, but people want, really, well, they like technology, but they also like to get more precise answers. So where we're shifting to is in trying to get away from humans making a whole bunch of these decisions about distance and species and all of that other stuff. We're trying to use new technology. So the first thing that we're using is what's called an ARU, which is up here in the left corner. That stands for Automated or Autonomous Recording Unit. And all it is a microphone that's a programmed computer. It can turn on and off at any schedule you want. It can record for days, months, even up to years. The amount of data you want is really only limited by battery life and SD card size. Okay, so we have literally run these for 14 months, every 6 times a day, for example. My technician sent me a number today. I have 2,242,000 recordings available for people to listen to, which is the functional equivalent of 40 years of your life. Anybody want to sign up? Okay, so this is getting back to sort of some of the next points. What can we do with this technology? You can put one ARU out and replace a human as a point counting device. The key thing is you can be out at any time of day, any time of the year, anywhere, right? You just got to get it out and go get it later. So you got to go twice. So we are able to do point counts now in the dead of night. We can do point counts in the middle of the afternoon. We can do point counts anytime we want, and we're getting a whole bunch of new information, new species we couldn't count before because we didn't go out at night. We have that now. We can put them out in early April and count the frogs, and also count the songbirds when they arrive, and do all kinds of other cool stuff. The other thing that's really cool about these is that we can hook them up to a GPS. And when we hook them up to a GPS, we know exactly where they are. We also know the exact time. And that's what we're doing with this project that is being funded here. What this is this is an ARU, that's an ARU, that's an ARU, that's an ARU, and this is a well pad there where I flew over it with a drone. So the drone is being used to do 3D photogrammetry to get me the height of the trees, the profile, exactly what's on the pad, what does the edge look like, high resolution, very detailed information. We also are putting out, I should reference here, there's also seismic lines often coming off of these well pads, and so we have the grid extending out over the seismic line as well. So what we're looking at is how does the vegetation and the type of vegetation on there influence the birds in terms of who is using the pad itself. And how that works is if you think about it, and I'm talking, you can tell where I am in this room, right? And it's because this ear is getting sound at a slightly different instant in time than this ear, right? And you turning your head, that's how you figure out where something is located. Well, by having all those ARUs out there, the time at which the sound arrives from a bird singing here to this one is slightly different than this ARU. And it's slightly different than this one, because sound travels at a fixed rate. So every one of those ARUs will pick up the sound at a slightly different time. When you take that and do some fairly fancy computer stuff, you can actually figure out where birds are within about 3 meters. So I can very precisely put exactly where that bird is, what it's doing, and how it's behaving. Now my student is still working up a lot of his results, so we don't have everything done to talk about today, but he gave me a couple of examples here. He has over 12,000 points within 3-meter accuracy where we're doing the spot mapping thing. We can figure out exactly how the bird's behaving, but instead of doing it one species at a time like we had to do with humans, we can do all the species at the same time, using this technology. So what he's showing here is basically the intensity of use of a clay-colored sparrow on the well pad, and there's an ovenbird. Here we have, 2 ovenbirds, and we can actually, with the computers now, figure out which ovenbird is which, based on space and also the way they sing. We can actually identify individuals from their song. And what we're able to get now is the intensity with which these birds behave, and when do they start moving onto the well pads. And we looked at the ovenbirds. Canada Warbler data is still coming, but the ovenbirds show that they're starting to creep in and use the edge of the well pad as the trees start to get to about here. And as they get taller and taller, the birds are starting to incorporate that as part of their territory. So the big take home for that is these well pads, when they do start to recover, when we do start to plant them, will have biodiversity value. It will be different biodiversity as it ages. The grassland species are going to disappear, and we're going to start to get the more mature treed specialists. This is just to give you an idea. We have, this is some of the well pads we've been studying, and we've got Canada Warblers in a couple of these cases actually creeping out and starting to use the well pad. We also have some of the birds that are living across the cut lines, suggesting that recovery, even at a fairly low level of vegetation, is helping things. Now the other thing though is that method I just showed you is incredibly intense. It takes a lot of ARUs to do it really, really well. So we're also trying to work on a technology that would allow us to do the same thing, maybe not quite as precisely, with ARUs to measure the distance at which birds are actually singing. So one of the things that you can do with an ARU that a human can't do is you can turn down the volume of the recording. So you sit there, you plop on your headphones, and this one would be a bird really loud, right? It would just blow your eardrums. Well, I can turn down the gain after the fact in the lab and reduce the amplitude of the signal. And that's what this is. This is the exact same bird. I just turned it down 50%. I turned it down 90%. And you see the signal starting to disappear. Well, I have data sets where I've played back song and also this data on the wells where we know exactly the bird is. We can start to see how sound decays as with distance. And the really cool part about that is we can then actually probably figure out if I turn the gain down to 99% of what the original recording volume was, I'm actually only sampling a 60-meter area instead of a 200-meter area. So now we can start to maybe use single ARUs for more refined questions without having to collect any more data. And again, the emphasis, anything that makes a sound can be counted. So that's the logic of what we're doing with the other part of this, which is blowing it back out the other way, which is scaling up and going to what we call the big grids. So the big grids are basically a network of ARUs and cameras that we're using, where we're trying to study how cumulative effects, true cumulative effects at very large scales, influences birds and mammals. So what we have is essentially 3 sites that are fully SAGD developed plays. Okay, so everything's fully developed, it's fully running. There's not likely to be much more footprint added because these areas are going full bore. We have some areas that have been, 3 or 4 areas that have been explored that if, you know, the price of oil goes back up, are likely to be developed, so they can be a before-after control impact type of situation. And then we have 3 or 4 areas that we right now we're calling our controls, and most of those are in provincial parks. What we do is at every 600 meters, we have an ARU and a camera that is functioning to be able to, you know, tell us what's going on. And this is really important for 2 major reasons. One, this is the scale at which cumulative effects happens. All of the data I showed you to date is focused on what happens at this point. Well, this point isn't cumulative effects. This point is one road right beside it. Cumulative effects is when I actually go across a larger landscape and I have a compressor, a well, 3 wells, and you know, a camp. What does that do, right? And are there synergistic additive effects? And the nice thing is we can do that across scales, right? Because these are close together, we can look at what happens at 1 point, what happens when you use 4 points, what happens when you use 9, 16, 25, and we're hoping to get at some kind of resolution of what spatial scale should we be talking about cumulative effects and being able to do that. Now part of this, again, right now I know this will work really, really well for amphibians because we've done it a ton. We know it works great for birds. These same units can be reprogrammed in different ways to do bats. We don't do bats on all of these points, but we're doing it on some. So we're doing the whole taxonomy thing. We also went out this fall to see if we could do better at getting the rut. So elk, the deer, the moose, when they're rutting, and also, you know, the canids. The reason being is a camera's a great tool, we love them, but cameras, the animal has to walk within 10 meters before you get a picture. These things, I could probably hear a wolf from 400 or 500 meters away. So seeing what we can use for all species, what this technology might be allowed to do is sort of the next step. So to come back to the Canada Warbler, what this is the ABMI website for what we call the reference state for Canada Warbler and what we call the current state. So the reference state is how many Canada Warblers and where was their habitat and where was it good if we hadn't done anything as humans. That's this map. This map is, now that we know what we know about age of the forest, we know about harvesting practices, where are the birds likely now? Where are they most abundant? And that's what this map says. Why I put this up here is it shows that there's been change. Certainly cumulative effects has led to less Canada Warblers based on forestry. And here we have sort of, this is the magnitude of the effect caused by forestry, this is the magnitude caused by agriculture in this region, and a variety of other things. Energy is relatively small. But one thing that's important here is everything, all those well pads, all those seismic lines in these models are equivalent. They don't take into context the width of them, it doesn't take into context the amount of vegetation on them. So as we get that higher resolution data, which is necessary, we can start to make these maps better, but we won't get those answers with point counts, right? Which is the traditional way these maps have been made. We have to get that high resolution data to show what birds really do around those features. So I forgot to call these best practices. I called them conclusions, but just change that and say best practices. The Canada Warbler, complex bird to design restoration strategies for it because it is rare. But I really do think this idea of population management units for it could be something quite reasonable. We could just have to go out and find them, locate them, and we can probably start to manage around them a little bit. The technology I'm talking about here, I think, is the next step in our evolution. ABMI started to use it, I use it a lot, and we've developed something called the bioacoustic unit. I'd encourage you to go on our website for 2 reasons. One, COSIA has sponsored a new web tool that we should release in the new year. Basically, where all of those recordings that I just talked about, you'll be able to see them. Some of them have been processed by a human. I can tell you exactly what's on them. You can see that data. Some of them, it's just raw data that's sitting there. A lot of it, we have computers now that we're working on, computers automatically going through the data. So for about 20 species that are species of concern, all of that 45 years worth of data has been processed by a computer that can automatically identify the species and tell us where it's occurring. We're trying to work on doing that for all species in the province. That'll be about a year or 2 before we're able to do that, but we're working on that quite a bit.